Cougars. Okay, in our last lesson, we were looking at numerical expressions and how to factor them. And when we looked at that, we saw that what we were doing was just creating a distributive model from a numerical expression. So today what we're going to do is we're going to be looking at algebraic expressions, and we're going to be creating distributive models from algebraic expressions. So we're going to continue our lesson in factoring expressions. And by the end of today, you should be able to, one, continue to tell me what is a greatest common factor in terms. You should also be able to tell me how do we create a distributive property, a distributive model from algebraic expressions and from numerical expressions. And then we are going to be able to see how to pull that number out when it comes to using variables. So by the end of the lesson, you will be able to explain and answer how do we factor algebraic expressions into a distributive model. Okay, so we're just going to continue where we left off yesterday. And yesterday we talked about greatest common factor, and factors being the two numbers that we put together in order to multiply to get a product or the answer to the multiplication problem. So we're going to be looking at the things that we're multiplying together to get the answer and then creating the same thing. All right, so let's say that I have a problem that looks like this. Because we know algebraic expressions, these are going to have letters because algebra equals variables. So we're going to say that this problem says factor 3x plus 42. All right, so they want us to factor that using the greatest common factor. So we're going to look at this and we are going to say, well, first of all, the two terms that we're working with are 1, the 3x, and 2, we're also working with this 42. So those are our two terms that we're working with. So we need to find the factors of 3x first. Well, when I multiply, let's use purple since I boxed it in purple. So when I find the factors of 3x, I know to get 3, to multiply 3, it's really just 1 times 3. So 1 and 3. Well, times x, right? Because I just pop that little x on there. So the x is just kind of like an added bonus because we don't know what the x is. So we're just going to stick it right there for now because we don't know what it is. So we're just going to say 1 times 1 and 3, but then we need to know at the end of this, we have to still multiply on the x. Now, let's talk about this 42. All right, so 42. All right, we know 1 and 42. 2 and 21. I probably should have wrote a little bit smaller. It's not all gonna fit. Sorry, you guys. 3 times 14. Okay, and I actually can stop right there. Do you know why I can stop right there? Looking for greatest common factor. I could keep going. I could say 6 times 7 if I wanted to finish this out. And then stop. But why could I have stopped right there? Look, if you see it, awesome. If you don't see it yet, I'm going to show you. So up above, 3 was the biggest number I needed. That's as high as I could go. So as soon as I knew that 42 had a 3 in it, I could stop right there because remember that 3 is the one that we're going to pull out. Okay, so if we look at this problem, factoring 3x plus 42, I need to figure out my common factor, which is 3. So my special number, my greatest common factor, the biggest number I can pull out of both of these numbers is, out of these terms, is a 3. That number is my multiplier. So I'm going to use this as my multiplier. So we're going to take this number and we are going to use that one on the outside of the parentheses. So 3 times what gives me 3? Well, 3 times 1. But wait, there's more. We know it needs to have the x on it. So we cannot forget the letter because it's really 3 times 1x. So 1x gives me 3x. I really don't need the 1 right there because remember that 1 is redundant. But we want to keep it because we want to make sure that we remember about it. Okay, plus we needed to make 42. Well, 3 times 14 was my multiplier. So 3 times 14 was my other factor. Okay, now let's double check this to make sure that I get the same answer on the outside. Right now I don't have a distributive property, so let's distribute. 3 times 1x plus 3 times 14. Again, I've just kind of cut out this middle part here. Just like yesterday, I'm just cutting out this middle and squishing together the parentheses and the 1x and the 14. This gives me 3 times 1x, which equals 3x, and 3 times 14, which equals 42. So there I have my greatest common factor. Of those two numbers, I have a factored expression, factored algebraic expression, because all it had left in it was the x. That's the only difference from what we did yesterday, was a letter. So the letter is just like an added bonus. Okay, let's look at another problem, because we know math has all kinds of problems, right? All right, let's look at I don't really like that problem. Oh my goodness. Why didn't they give us different ones that are better? Okay, let's do this one. 8y minus 44. Okay, so we have two factors here, 8y and 44. So we're going to look at both of these. Again, slow it down. Let's check it out. We have 8y is our first term. We need to factor 8y. So let's find the factors of 8y. Well, the factors of 8y are 1 times 8, 2 times 4. And now I'm just going to say times y, because I cannot forget the y. Okay? Why? Because the y is important. That's why. Don't forget about the y. Okay, now we need to worry about the 44. So we got to factor that guy in. All right, so we've got a 44. So let's factor that. 44. Again, just like last time. 1 and 44. 2 times 22, not 3, 4, and 11. And I think I can stop there because what do you notice right there? What is it that you see happening right there? Yeah, I see the 4. So I don't even need to see if there's anything else that can go into that because 4 is going to be the greatest common factor. Oh, sure, they have a 1, they have the 2, but the 4 is where it's at. So the greatest common factor of 8y and 44 is 4. So that is my multiplier. Okay, oh, you can't see multiplier. Boom, multiplier. Okay, that's my special number. He gets to go on the outside of the parentheses. Okay, so we're going to put that number on the outside of the parentheses, and we're going to figure out what did we use that number to do. Again, we're just reversing what we did. So to get 8, we used the 4 times 2. To get to 44 with our special magic number, we used the 4 times the 11. That was our pair that we used, our factor pair. And this problem said we needed to subtract. So we better make sure we're subtracting. Okay, now we need to go and make this a distributive property because right now we're in that middle stage. It's not quite a distributive property yet. It's not a distributive model. So this 4, our greatest common factor here, needs to be on the outside of the parentheses. And then the numbers that I used on the inside, oh my goodness, you know what I forgot? Guys, you didn't tell me. I forgot my y. I gotta put that y in there. Otherwise, when I go back and check it, it won't be equivalent. So maybe we need to start circling that out there so we see it and it stands out to us like a blinking neon light. Don't forget about me. Okay, so now we're going to say 4 times 2y gives us 8y. I knew I missed my y because when I checked it, I didn't have 8y. They weren't equivalent, but now they're equivalent. And I'm using my special number 4 to multiply by 11. I already did that. So we're just rewriting. Okay, and now we have to put this as subtraction. Okay, now let's turn this one into a distributive property. There we go. That looks way better. Sorry about that. All right. So this equals 4 and 2y minus 11. So I'm just taking these two inner numbers, these two terms, and popping them in. And now when I look at this and I actually factor it out, when I factor this out, 4 times 2y gives me 8y. 4 times 11 gives me 44. 8y minus 44, 8y minus 44. Boom, they're equal. They're equivalent. Okay, ready? Your turn. It is your turn to do a try it. I know, it's the moment you've been waiting for. I know how much you love these to check your understanding, to see how you're doing. Do you get it? Do you understand what you're learning? All right, your problem that I want you to factor is 7x plus 49. 7x plus 49. All right, hit pause right now so you don't hear me talking. Otherwise you will, and then that'll spoil the surprise at the end. We don't want that. Okay, hit pause. All right, first number that I'm going to factor, 7x. All right, so 7 times x. Well, this one is just 1 times 7 times my x. All right, and 49 is the second term. And this one is 1 times 49. And 7 times, well, 7. Oh my gosh, you guys, I see it. I already see it. I see it. It's right here. Oh my gosh. Oh, and I don't want to forget that. Okay, so I know that the greatest common factor, the special one is, it is 7. That is my multiplier. So I am going to now do 7 times 1x plus 7 times 7. And are you ready for the grand finale? Your answer should be 7 times 1x, or 7 times x. You can just have an x there. You don't need the 1. Plus 7. This is the final. That is your answer right there. And apparently, I need a new green pen. Okay, now go back to the top. Check your work. How did you do? Go up to the top. We're going to answer our essential question. How do we factor algebraic expressions? How do we factor algebraic expressions? So look at that essential question up there, and I want you to answer that somewhere on your paper, and then go back through your notes. Is there anywhere that you're unclear? Why did Miss Englander do that? What is she thinking right there? Did she forget something? I'm really confused about this. Go ahead, make yourself a note so we can talk about our notes tomorrow. All right, when you are done, you may head on over either to Google Classroom to ask me those questions right away, or you may head over to your classwork tab to see what your work is for today, your practice work. And as always, you know, let's make it a great day the Cougar way. Thanks for all your hard work, everyone.